this computer just as a backup. And we're just setting up live streaming right now. So Lisa is here with me.
Hi, nice to meet you.
Hello.
Okay, live on custom live streams.
So we're not seeing it right now. Should we ask Virginia?
Virginia.
Mm-hmm.
So we're following their instructions on the YouTube streaming workshop PDF. We're on going live. Point 2. And we can't find the live on custom live streaming service within like the selection of the Zoom for more options.
What do you see? Can you send me a like screen capture of what you do see? Sure. If that one is not an option, you could go.
I'm going to share the screen.
Yeah.
Okay, so here's the screen.
Mm-hmm.
Just take a look.
So I think when you share your Zoom screen, we can't like, it's very smart and you can't share the Zoom of the Zoom screen. Like I see your desktop and all of your presentation and your notes and all the other things.
Right.
But I can't see you because Zoom knows to like not show itself. So can you just take a screen capture and then share that?
I'm just dropping it into the chat.
Yep, that's fine.
Hey, Virginia, do you see that yet?
No, I do not see it in the chat yet. Did you send it to me?
I think we're having some difficulty getting the image to upload. But it says stop share.
I'm going to stop sharing.
It says pause recording or stop recording. Those are the only 2 options.
Okay, so you maybe need to turn on the live streaming in Zoom on their website. So if you go to, let me just share my screen. So if you go to Zoom's website, so zoom.us,
Yeah.
and you go sign in, I'm going to sign into our DigitalFUTURES account so you can all see our meetings there. But under your settings here,
Yep.
when you're in your account,
Okay.
you can scroll down and there'll be a setting here to allow live streaming.
Okay.
You have to find it. It's very hard to find because there's so many settings.
No problem. I'm just going to go.
The other option is if we can't figure it out today, we the best option is also to just, as you did, record the meeting and then upload to YouTube afterwards, so that students can follow along, even though it'll be maybe like an hour or so delayed
Yeah.
from the actual workshop. They can still follow and watch the videos. And also, I find in my workshop that I'm teaching, many of the students come back and watch the videos over and over because they like to pause or re-listen to things that they didn't get to take notes on. Yeah, so all the way at the bottom here, you'll see this one, allow live streaming for meetings. And so you will need to turn that setting on if it wasn't already on in your Zoom account.
Okay, so we're just at the very bottom of the settings in the Zoom.
Yeah.
Is this something that we can share the screen on?
Yeah, you can share your screen if you can't find that.
All right. Do you see us?
Mm-hmm.
Okay. So we're going down. Well, live streaming. I saw it.
Yep, there. So click that one. Yep. So I don't know if it will work automatically. So once you've turned this on, it might not work in this current meeting because it's already kind of like started. So you might just have to upload this recording, and then next time you should be able to have that button to do the live stream.
Okay.
Does that make sense?
Very cool. Is it worth me resetting?
Yeah, I think you should do that.
And it turned
Or
it
no,
off.
that turned it off. Don't reset.
Okay.
I don't know
cool.
what I'm talking about.
No,
I
it's
don't know
cool.
if there's a, yeah, it should be fine now.
Okay.
Maybe just check it at the bottom if there's a save settings button, or maybe it automatically saves once you just close out. Yeah, no,
Yeah,
I think that's
I
fine.
think we're
It
good.
should just save.
Cool.
Okay.
Okay, beautiful. All right, everyone, we're going to start. Hello. I wonder if everyone could come on screen, that would be ideal. We're a nice small group, and so we can get to know everyone. Hey, Marissa Bell.
Morning.
Hey, Lewis. Hey, Lauren. Hey, Sharon.
Hi.
I see R Jam. What's your first name, R?
My name is Reza.
Hi, how you doing? Hey,
Hi.
Ivy. Hey, Chengwen.
Thanks.
Chengwen, are you up for sharing your camera? Maybe you're not there. Okay, folks. Well, I'm really so very glad to see you. My colleague Lisa is here with me, Lisa Jiang, wonderful associate. Say hi, Lisa. And I'm going to suggest that the two of us introduce ourselves, and then I'm going to ask everyone in the room just to share a few words about where they're coming from too. We can take about 20 minutes on this. Then I'm going to launch the charrette. That is the design exercise that we're going to be following through for these 4 days. I think that I hope that it will be really a pleasurable one in which you improvise some materials and then develop some textiles and then develop that into a visualization of some possible personal boundaries and space making. We're going to be using Miro, and we'll send you the link for Miro, which is a pasteboard where everyone can see each other's work. It's just been set up, and we were having some problem with Basecamp this morning. It was out of commission, but I believe it's back up now. I'd really appreciate everyone that's on camera just to give me a thumbs up as to whether they've been able to see Basecamp yet. Could you just give me a thumbs up if that worked for you on camera? Thanks. Okay, so some people aren't responding and some people are. Those of you that haven't been able to get to Basecamp yet, please have a look for the email that invited you, and you'll just it's a very fast setup. You just need to set your own login and then get there. And that's the place where we'll be messaging and sharing quite a bit of notes. For example, this morning, I sent an outline of what we'll be covering today. And I'll try and do that every day. So why don't we just get started then with, and by the way, Virginia, thank you so much for joining us. We really, really appreciate your support. This Inclusive Futures workshop has some pretty extraordinary colleagues working behind the scenes. Virginia and Gustavo are two within the Digital Futures Network. And meanwhile, I'm joined by my extraordinary colleague, Lisa Jiang, who you can see named LASG PBSI Studio. Lisa, I'll suggest that you change that label, even though you're LASG PBSI Studio. I think that you could also be Lisa.
I'm logged into the wrong account, sorry.
You can just, it's cool, but just change the name. It's all right. Even before we do this, I'm going to just go for a walk in the studio because I'd like you to see where we are. So I'm sitting here in my corner, and this is where I work. And here you can see a library and some samples and a number of things that we're working on. And a whole bunch of drawings for the current sculpture, culture, and current environment. And then here are my colleagues. And I guess you can tell from what we have here that there are a number of different things that we're doing in the studio. For example, fabrics with our beloved friend Iris van Herpen. You can see quite a bit of that work, including some original prototypes from the Glitch series, for example. And then digital modeling work in motion. Some more fabrics. We're going to be bringing those to Paris Fashion Week next week. And then one of the fabrication places in the studio with a little print farm. And then some heavier workshops as well. I have to say the workshop is definitely one of my happy places. And then we have some heavier machinery. Laser cutters and so on.
Is it frozen for everyone? Up there.
Sorry about that. I just went out of range. Sorry about that. I'm back. Anyway, so I hope that I won't show you all of the stock rooms and so on. I'll just show you that we're outside. There's some sunlight here as well. So that's a Toronto messy industrial sky. And our old studio is being taken over by condominiums, so you could see construction in the distance as well, for better and worse. Okay, so that's a little taste of the studio. And I wonder, maybe I'll just give a couple of words of introduction for myself. And then Lisa, I'm going to ask you to introduce yourself, and then I'm going to ask everyone in the circle as well. So I'm a sculptor, and I love researching and thinking as well. I was trained first in visual art and in theater And then I got involved in instrument making and stage design. And I got quite involved in architecture for quite a while. Started doing large buildings, public buildings anyway. And then became really fascinated with the experimental possibilities of digital fabrication and textiles above all. Started collaborating with textile designers, in particular, a wonderful individual from Philadelphia, Warren Seelig, who taught me so much about how fabrics worked and how the hand of fabrics emerged and their behaviors. And it really struck me that was an extraordinarily valuable way of thinking about large-scale building, as well as small-scale intimate building. The sense that rather than making something solid and cutting it and shaping it and making outside form, that you could work with filamentary forces and tensility and build up really very, very delicate kind of elastic qualities that would create fabrics that then would create substance, and some of those things would freeze and mineralize and become compressive and become formal as well and have shape. But some would be much more about stretching and following and flowing. And those dialogues with textile artists have changed me pretty much forever, I guess, in my own thinking anyway. And so that the result of that is quite a hybrid practice now. In the last few years, a friendship with Iris van Herpen has grown into an almost constant dialogue with her. I'll be together with her again in a few days for her latest collection, the 15th that we've done together. Meanwhile, I have wonderful relationships like my beloved colleague Lisa, who is an extraordinary couture designer in her own right and really one of the most important people in the studio. Lisa, I wonder if you would give a few words about your own background.
Sure. My name is Lisa Jiang, and I've worked with Philip for, I think, nearly 3 years now. I've been working at Philip Studio. My background is also, I started in fine art, and then when I studied in undergraduate at university, I studied fashion design women's wear at Central St. Martin's. So I started in fine art and fashion design, and now at Philip Studio, moving into sculpture and architecture also. And me and Philip actually met through Iris van Herpen also. I was interning at her studios in 2017. While I was still at university, I was interning at her studio for 4 months for one of her couture shows. And Philip, his relationship with Iris means that he visits Amsterdam twice a year and Paris twice a year also. So just in that 4-month internship, I already met Philip twice. And then I returned to Iris's studio to work as her personal assistant, and we collaborated more with Philip Studio. I got to know some of the rest of the team also, working on collaborative projects together, including the fabric development for the collections and a really exciting mannequin development project that we're working on. So like 3D modeling and digital fabrication techniques we were working on together. And then after that, I was at Iris's studio for a little bit less than a year. And then I moved to Philip Studio initially to work as a bridge between the two studios so that we could really try and focus on the fabric collaboration together. And in my first few months, we concentrated a lot on creating some new fabric samples together. And then I started moving in also to the sculpture side and the architectural side of the design at Philip Studio. So now it's a bit of a juggle between the fabrics and the sculpture. That's where I'm at.
Thank you so much, Lisa. And I wonder whether we could continue a go around where I ask each of you to introduce yourself as well. Marissa, do you want to start?
Okay. Good morning, everybody. My name, can you hear me well?
Yes.
Good. My name is Marissa Belmurat. I am located right now in Atlanta, Georgia. I am a PhD student at Georgia Institute of Technology. My background is, I'm a PhD student in the architecture department. My background is as an architect. I studied architecture and practiced for many years after graduate school in New York and then in Paris. I also, had always been very involved in theater studies personally for just a love of theater. And then after sort of a while in my professional work, I started to gravitate towards theater, scenography, and design for performance because of the sort of intimate nature. I sort of missed the scale and the intimate nature of projects. And I also liked the ephemerality of them, of the theater projects. And so I, in Paris, really focused a lot on working with theater and dance groups as a scenographer. I also got involved in costume design and just the design of structures that could change and that could transform. So there was always this incredible interest in this. And part of my reason for going back to school after many years of professional practice was really to sort of explore, expand what architecture in this kind of more intimate sort of way of engaging could be. And so that was really what spurred me to go back and study architecture, get a PhD. And I am working with Lars Spybrook, who has helped me change a lot of sort of my interest and really sort of kind of focus me in my work. So I think that's sort of a kind of a short sort of synopsis of me. I'm very excited to be part of this workshop. I'm looking forward to it.
Thank you so much. It sounds like we have all kinds of common ground.
Yeah, that sounds like that.
Lewis, please.
Yeah, hi everyone. Well, my name is Luis Matias. I'm from Peru. I'm 21 years old, and actually I'm studying architecture degree. I don't have a lot of words to say, but I would like to say that for a few years I have been very interested in the world of science and experimentation. So that's the reason for I decided to take this workshop. Also, I follow the work of you, Philip, and the work of Rachel Armstrong, and I'm so interested in what the human and what the humans as a society can do for the future, and to think in, I don't know, in 50 years later. Thank you.
Thank you. Lauren, please.
Hi, everyone. My name is Laura Mosley. I have a background in fine arts, but for undergrad, when I came to New York, that's where I'm located right now, I did my undergrad in architectural technology, and I did a specialization in digital fabrication. And since then, I've been working with the university as a digital fabrication specialist, and I'm also interning at KPF as their digital fabrication intern right now. And last summer, last fall, I started to pursue my master's in architecture degree at Columbia GSAP. So that is kind of where I am currently. But fabrication has always been a passion of mine since doing those classes, and performative fabrication and architecture was something I was always really interested in, and I'm looking forward to the workshop.
Thank you. Reza.
Hi everyone, I'm Reza. I'm from Iran, and I'm an architecture design postgraduate from Istanbul Bilgi University. I have worked as an architecture designer for more than 50 years, but in the last 4 years, I concentrated on multidisciplinary project between fashion, art, and architecture, and producing garments, architectonic parts as clothes and garments. And I'm very happy to attending to this workshop, because until now I have just produced digital products about fashion, but now I want to have physical experiences about that. Just that. Thank you. And me and Shirin are couples, are together here. Just to know, just to inform you.
Aha. Do you mean the curtain that I see with the beautiful
Yes,
shadows
are the
and
same
Sharon?
place.
Oh, I see some. There. That's very interesting. I see this now. All right, Ivy, why don't you go next?
Oh, hi. My name is actually Tong, but I don't know why on the Zoom it shows that I study architecture, and I graduated from University of Pennsylvania. And after that, I'm currently working at MAD. I don't know whether you guys know, an architecture firm in China. And yeah, I'm very much into like how nature can teach us in like how we design. And yeah, and in my projects before, I always reference Philip's project. So that's how I joined, like how I'm interested in this workshop. Yeah, and currently I work, I'm working with a textile firm in China with some very small projects. Yeah, so that's it.
And whereabouts are you in China?
Sorry?
Whereabouts
Where
are
am
you?
I in?
Yes, where are you
Oh,
located?
I'm in Beijing.
Oh, in Beijing.
Yeah.
Thank you. Sharon, with the very mysterious patterns on your curtain that I've seen before.
Hi everyone, my name is Shirin and I'm an architect with more than 10 years experience in design field. And in recent years, I have worked on multidisciplinary projects that are about architecture, human body, and environment. And I'm so happy to be in this amazing workshop.
Thank you, Sharon. And Cheng Wen, are you there? Okay, well, it looks like we have a silent member, so that's okay. All right, colleagues, well, I'd like to know if you have been able to see the notes that I posted on Basecamp this morning that give the outline of the first design exercise. Could everyone give me a thumbs up if they have seen those?
Yes, yes.
Okay. Okay, that's great. So let me just outline what I'm hoping we're going to be able to do. The outline of these 4 days, we're going to be working together for 2.5 hours each day for today, tomorrow. Then we'll have a break on Wednesday. I'm going to ask you to develop your work more. And then on Thursday, we'll have a more developed design review and then a final session on Friday morning. Each of those days, with the exception of the last one, we're going to be having 2 presentations, one from Lisa and one from myself, together with some discussion and review of your own work. And tomorrow, I hope that you would be willing also to show your own work. And so I'm going to ask for you to prepare just maybe 3 or 4 minutes, a rather short picture in which you share some images, because I think it's a very special group. And it's a chance for us to get to know each other. I think that all of us would really enjoy being able to learn about your own work and the things that you're reflecting on. Does that sound okay for tomorrow? if we ask you to make a short presentation each? Thank you. So let me describe the first exercise. I'm going to try to reinforce the sense of making cellular tectonics. When I say tectonics, I mean architectonics, the act of putting elements together. That's perhaps a familiar term to those of us who are practicing architecture. But it can also apply to textiles and fabrics and couture as well. That is the idea that rather than thinking of something first as an overall shape or form or boundary, we can think of the fabric, and we can think of that fabric as being cellular, that is, made of many small parts, accreting and multiplying together and interweaving and interlinking. Perhaps they're in 2 dimensions, that is, put part to part to part to part, like it's a pattern, as if it's a membrane. Perhaps it's in 3 dimensions in which they start to move together and make space trusses or interweaving lattices in which they start to occupy space as well. But above all, the sense that a cellular organization of elements can make for very, very special qualities is something that I hope that we're going to be able to practice together. For some of you, this may be something that you take for granted. For others, it may involve some innovation. I'd really like to celebrate both of those things and to really treat this as a very experimental passage that we share together, in which we draw on our own disciplines, on the things that we know very well, and then use them to look at some qualities and create them very directly through this passage of 3 or 4 days, so that we could rapidly develop a sense of quite a deep vocabulary for resilient cellular textiles. Now, the very first thing I'm going to ask you to do then, which is after this workshop and for tomorrow, I'm going to ask you to gather a couple of 100 elements. They could be small elements that you have just conveniently around the house. Perhaps you could get them from a grocery store or a hardware store. It could be paper clips. It could be bamboo. It could be small sticks. It could be any kind of element that is somehow convenient to you. You could chop things up and manufacture them. But the point is that I'd like you to have a lot of them. And I'd like them to be relatively inexpensive, so you don't mind kind of abusing them and pushing them around and consuming them. And I'd like them to be relatively uniform. That is to say, they don't have to be exactly all the same, but the idea is a very large quantity, a couple of 100 anyway, at least a couple of 100. And what I'm going to ask you to do is a very simple exercise, which is to create a fabric out of them. How would you do that? Well, I'd like you to invent some ways of doing that. It could be as willful as using hot glue and sticking them together and just freezing them together. You could use zip ties, you could use thread, you could use rubber bands, you could interweave them. Let's see how to start building things up. They could be done professionally, that is to say, using textile craft of thread and careful joints, or they can be done as an unapologetic amateur, where you simply see how these things can accrete. And I think that both of those approaches, both using meticulous craft, things that you know already, and open sketching, where you're very deliberately using a kind of a hacking in which you see things emerge, both of those qualities can be extraordinarily fruitful and hopefully can reveal some things to each other. So tomorrow morning, at least tomorrow morning, my time, I realize that you are in different time scales where you are. Tomorrow morning, I hope that we'll be able to start to speculate about the qualities that happen when these individual cells cluster together and interweave. and the kind of emergent qualities that result, the small groups, the subgroups, the groups of groups, the groups of groups of groups. What happens in gravity? What happens when it flows? Could we speculate what kind of boundary around our bodies that might make? Could we speculate about perhaps a scale too? In other words, is the material that you're using something that seems like a model? Or does it seem full size? Did you just hear a train going by behind me? I just couldn't hear for a bit. This building shakes every half an hour or so because we're in an industrial area. And it's one of the things that helps us keep time. Right, Lisa? It's like, oh, the train's gone by. Anyway, I'm back. Okay, so I hope that gives you a sense of the kind of first exploration. And I'm going to suggest that maybe we come back to this after I give a bit of a talk and then Lisa gives a talk. So what I'm going to suggest is that we have a couple more hours right now, about an hour and 3/4. So we're going to try and cut off at around 12:30 every day. My time, that is Eastern Standard Time. It's 10 o'clock right now. It's a little after 10:30 right now. So I'm going to ask if you have any questions about this first assignment. And then I'm going to share screen and give a bit of a lecture for about 45 minutes. Do you have any questions?
I have a question about, we don't have to really concern ourselves with the attachment method is the structure. In other words, we kind of dispensing with an idea of a warp and a weft. We're not weaving these together. Or is that part of the diagram later on?
Well, what I would say is that you're very welcome to use traditional textile methods, including weaving and speculating about how a warp or a weft topology works. Let me say a little bit more about that, but at the same time, that can come out of the assembly. Now, I should also say, okay, how are we going to share this work? I'm going to ask you to share it by physically making some samples, taking some quick photographs, and posting them on the Miro pasteboard. Each of you will have a section of a collective pasteboard, and you can also sketch and diagram in order to make notes about this. So the idea is that you're creating something of a kind of a lookbook for a possibility. Now, Lisa, I'm going to ask you to speak about this as well, because Lisa and I have come from different places. Lisa has a fundamental depth in fashion design itself, where I come to this as a sculptor and stage designer, as an architect. So I tend to prioritize sampling and prototyping and then rather precise drawing and modeling. Lisa, could you speak a little bit more about the sketches that you would do if you're going into this exercise? What's a lookbook?
So I think to answer a little bit more about the question for the warp and weft and weaving, I think a really beautiful thing about this workshop is that it brings new connection ideas for tessellating fabrics. So the material choice is interesting. And then I think almost equally important is the technique to connect your tessellating pieces. So warp, weaving and knitting, traditional fabric making techniques is one option. We're going to talk about a few other connection possibilities in the presentations that we're about to give. And we really encourage like other experimentation for that. And then for the lookbook, for me, I go back and forth between 2D sketching by hand and draping on the mannequin. So again, I think for the first exercise of creating a swatch of fabric that's a little bit drapable, it has some hand and 3D, like something that you can play around with on the mannequin or even a half scale mannequin. And then I would create a few different 3D drapes and then some more sketches from that, and then back onto the mannequin, just back and forth like that. And then photography, the drapes and sketch developments. Both I would like post in this case to the Miro board, just as, at least for the first day, as a thought process to start developing the final silhouettes.
Okay, so I hope that that gives a bit more impression. Let's also just mention the terms warp and weft, which may be familiar to some of you and perhaps less so for others. When I think of warp and weft, I think of two fundamentally different forces that relate very much to architecture as well as to fabric. That is, I think of tension and compression.
Mhm.
Now, those of us that are architectural designers will relate immediately to tension and compression. Compression, the kind of things that are solid and tough and that like a brick, for example, or a stone, or an inert strut, perhaps a column or a post. Tension, the kind of extraordinary quality of pulling on something, and perhaps it works in elasticity, but we know how very, very strong something can be when it's acting in tension, because it doesn't need to worry about buckling or holding itself. The act of pulling it keeps it in space, because the things that are pulling it are usually other than what we speak about when we speak about tensivity. Those forces come, or those fixtures come from outside the question. So tension is a very special force. It has extraordinary material efficiency. Compression is arguably one of the most familiar qualities that exists in Western architecture. When we speak about Western architecture, I think of the world of stereotomy, stereotomy, that is stereos from the Greek solid, and tomachia, cutting from the solid, carving out from solid masses of stone and earth and clay, and making compressible, strong individual blocks that build up and that resist gravity. It's one of an extraordinarily satisfying art of creating form out of earth. Tension is so very different. If we think of the way vines work, or branches or twigs, and all of the kind of canopies of natural growth, and the way they wind out and have compliant tendrils, filaments weaving through space, and how that makes great meshworks. These are perhaps two fundamental vocabularies that have been with human building since the beginning of recorded history and before that. And so it seems very strange then that a classical tradition of architecture would favor only compression, almost only compression, and very, very rarely tension. At least in a Western tradition. Now, this is not going to be a political workshop, but what's being pursued in this workshop is to establish some vocabularies of compliant design that certainly include tension just as much as compression. Now, that's just a little reflection on Western architecture, and I mentioned that those could be seen as related to warp and weft. Well, if we think of a loom, that is a traditional textile construction, we can think of the warp lines as the ones that are stretched and fixed, making a kind of a harp of multiple aligned filaments. And then, if those are all in line, then we might weave in and out, pushing in the transverse direction, a weft thread. And by virtue of that pushing underneath and over and under and over, it will tend to be pushed And it will tend, therefore, to work in compression compared to the tensile lines of the warp. Now, I'm exaggerating a little bit because a weft thread in textiles will have tension in it in turn. And in fact, we can pull it taut and pull it back and forth. And if we pull that weft filament tight enough, in fact, it'll be enough to displace the warp. And then you might have a warp thread going up and down. And you can see that happening in some cases. But typically, we can think of the weft as being more inert and compressible compared to the weft being compressible compared to the warp, which is held in tension. Now, this becomes quite a bit more complex in a really lovely way when we work with automated looms, and then we move different layers of the warp threads up and down selectively so that we make a shed in space so that we can pass the weft through just part of it at a time. And then we move it again, and then we pass the weft again, and it goes through a different shed. And by going up and down, alternating different sheds of space are made, and that's what makes our familiar patterns of weaving in varying patterns, the simplest one of which is just a strict alternating pattern, and then the more complex ones which can be as complex as digital jacquards, where you can electively pull up any single warp line at all and then pass a weft through it. And therefore you can get very complex patterns, at least as complex as the number of weft and warp threads, which starts to be the same as pixels in space in terms of the potential complexity. Now, I'm just using words to describe this, and so that may not be the best way to introduce the idea, but I hope you get a feeling then that there's pretty strong tectonic fabrication link between architecture and textiles, just by virtue of their fundamental craft. What I hope is that we'll be able to show some more images that relate to that along the way. Any questions about warp and weft and tectonics, or any reflections? I'd love some more concrete examples of this. Can anyone help me with this to make it clearer? Maybe we can come back to it then.
I was thinking a little bit of a spider's web.
Spider's web.
Not quite warp and weft in the classical sense, but there are moments of tension and compression, in the geometry, in the way that how different filaments function, and towards do you see what I'm saying? So that it could be simply a case of how things function, that they also change their nature as warp or weft in a particular configuration. I don't know if that's clear.
Well,
yeah.
It's an incredibly beautiful example, and if we think of the aramid protein strands that a spider will extrude, I think it might be true to say that a web can function almost exclusively in tension, that is completely stretching every filament out, and that's because it has the anchor of any number of surfaces around it, of branches or bricks or any other surface. And so we have this whole kind of like framework of compressive anchors around it, and then we have this extraordinary tension web in the center, which then changes in really interesting ways when a cocoon or a victim lands in the web, because then once you have that, then may we say that we have something approaching a tensegrity network, that is a tension integrity network, the famous term that Buckminster Fuller used, tensegrity, the coined word that he invented in the 50s, meaning tension integrity, meaning that what is continuous is a tensile net, that's anchored outside of the frame in earth or another structure. And then inside that continuous tension net, there are compressive elements floating. And so one example would be the poor fly that's caught in the web. It's a bundle that's very tough, and it can displace and push and actually create its own kind of environment. And if we think of larger webs of tensegrity networks, then we can think of very, very interesting structures indeed. Notably our own bodies, because after all, the outermost parts of our own bodies are tensile sheaths. The epidermis and the outer fascia of our bodies are tensile networks, and floating inside those are a series of bones, which are pushed apart and held apart by the tendons and the muscular network. So it's really lovely to think of the qualities of tensegrity networks. And I think that there might, we might play with a relationship between a spider's web as an extreme and our own bodies, and perhaps architectural structures like Fry Otto's lovely tensile nets of the Munich Olympics, or Janet Eckelman's lovely hung sculptures more recently.
Yeah.
Well, I'm just gonna start up a PowerPoint then. So I'll just share my screen on this. And I hope you can see my messy screen now. And I'm just going to show you what I'm going to show you. So this is the length of what I'm going to show you. And it's going to be a meditation on kinds of space, an argument for some new ways of conceiving of fields, talking about a rather sort of emotional sense of my own training in space. Going to use some examples from medieval art, and then I'm going to go show you just some examples of contemporary work that Lisa and I are doing in our own studio. Tomorrow there will be some more extended discussions about sketching methods and explorations, but I'll just start here. Transitional fields. I mean, transitional fields is a term that Donald Winnicott, the American and British psychologist from the late 20th century, used to mean that kind of delicious sense in which you're a baby and yet you are still a part of your mother. That technical term in which you are much more than an individual, and you are a composite being, and you're in transition, and the two of you are one, and yet you are becoming two as well, is the body of an amount of psychology in which he talks about transitional objects, that is like the diapers and the loveys and the things you hold when you're a baby, as being really important for the way that you find your own identity. And in turn, Winnicott talks about transitional fields, works of art, sculpture, and architecture as having an extraordinarily valuable function in bridging the gap, in making the connection between us and the world, opening boundaries and bridging boundaries. Now, I've just given a rather quick cluster of terms in speaking about transitional fields and infant psychology, which I'm going to come back to. But what I'm trying to do is I'm going to try to set up in this talk something of a manifesto which says that some different terms, rather than the polarized ones of everything black or everything white, everything a figure or everything a field, might be relieved in a search for a kind of continuum. So that's the agenda of this talk. The work that I'm going to be showing has been under development for a while. Here's some previous work, such as the Venice Biennale for Architecture for 12 years ago, Paleozoic Ground, quite an interwoven, deeply immersive system. Or Epiphyte Chamber done in Korea, in Seoul, a couple of years after that. This was in 2013, in which I hope you can see the kind of stratified lines and thickenings and the expanded lace-like networks of elements, and also lines of chemical systems in which there are vinegar batteries that generate their own current, and layers of actuators and webs of quite interwoven systems working and chorusing all together. Rather more recently, the studio has started to work beyond the kind of immersive fields in quite strong structures. After rejecting strong structures for quite a while, after rejecting figures and polarized kind of nests, it's become really very attractive to include them as well. I mean, the kind of delicious sanctuary that happens when you make a shell around something where you can be unapologetically alone in a sanctuary. And I've been really, really enjoying making very, very porous kind of shells that are extremely strong, that acquire architectural structural strength, while at the same time still being very able to have all kinds of conversations through them because of their cellular open forms. And some of those are quite densely saturated with synthetic biology, with chemical contents that act out the primary kind of dynamics of protocells, that is, prototype cells using ingredients like copper sulfate and potassium ferric cyanide, which are compounds which can weave together and work very effectively to make chemical veils and really lovely catalytic reactions that start to speak about a very, very lively organization. Now, I see that we've got a couple of new colleagues that have joined us, and welcome, colleagues. I'll just ask you to maybe introduce yourself a little after I give this talk. So in this more recent series of spherical constructions and meshworks, quite concentrated behaviors are housed. That is, webs of flickering vibration and light and quite immersive sound. And some of these move also into couture, and I'll just show one, and I have to turn off the sound of it. Which, for example, is this dress that was done especially with Lisa Jiang's work and working together with Iris van Herpen, in which layers and layers of fabric made rippling kind of boundaries around a body. So I hope you can see the kind of continuity between some of the larger scale constructions and the runway work that we've been doing as well. This is developed very similarly to the architectural constructions by building up many layers and going through many cycles of fabric design. So as an introduction to the work, I hope you have a feeling for those different examples. And I'm going to try to speak now about some new models of space and relationships that I think might really this discussion. Let's start with how we think about space itself. When I think about space, I refer to the kind of education I had as a child. Perhaps it's like yours, where we learned about outer space. And through extraordinary inventions like the Hubble telescope, we were able to see deep, deep into space and see the extraordinary reality of galaxies and of innumerable points and stars, and clouds, and nebula. And yet, the fundamental quality of what we see in this kind of image taken from the Hubble telescope is a sense that in between each of those points, there is emptiness, void. Yes, it's absolutely true that there are those infinitesimal planets, just like the atoms that are inside mass. But in between each of those is, I was told, a sense of a kind of a silent emptiness. And that sense of what space is, the emptiness of space, was perhaps something that was really emphasized when I was young. I wonder whether it was similar for you. The idea that just like the emptiness of space, there's a kind of a silence and a gap between each one of us as well, that ultimately each one of us is alone, that we'll die alone, that this is true, that we are alone, that each one of us is an island, and that this could be somehow a very beautiful quality, being proud somehow of being able to live with the cold reality that would say that instead of a preceding age in which there was a picture of a religion, of the presence of God, the presence of our parents, the presence of a civilization, the presence of nations and families and communities taking care of us, and above all, being there, filling space. A kind of remarkable generation of thinking through the late 20th century focused very much, I believe, on emptying space, making it proudly empty. The idea of atheism as a kind of pride. I'm showing some images. Go ahead. Hello. I'm showing some images right now. I'm just going to try and get this unstuck. There we are. By Alberto Giacometti, the extraordinary 20th century sculptor. And these images that I'm showing you were very significant sculptures in the 1960s in which they were made, in which individual figures were almost eroded by space in a kind of a delicious sense that everything is silent, God is dead, atheism is a beautiful reality. Here's another image by Giacometti, in which I think we can see that vision of space as being a kind of eroding quality, leaving us alone and silent, is held. And perhaps that gives a sense of an architecture that might respond to that idea of reality. Now, I'm going to disagree with this idea of space, but first of all, I want to reinforce it as a very great truth and a very powerful thing, because I think it's had such an extraordinary influence on many of us. And I would suggest that a kind of architecture could be built out of that sensibility that space is empty. Perhaps the idea would be that if that's true, then we concentrate on architecture that is as solid as possible and that creates as much freedom as possible, allowing the kind of freedom of moving across a great stripped stage in which the earth is made solid. And I think that this results in a very beautiful kind of architecture, which we might recognize the architecture of late modernism, such as Mies van der Rohe's extraordinary plazas and buildings. Perhaps some of you have seen these structures in Chicago and Montreal and Toronto and Berlin and Chicago. The kind of clear podium and then minimal, beautifully precise elements that are on it, really celebrating the sense that humans can be free and move unconstrained with a minimum of kind of interference across these kind of solid, stripped, compressive, hard surfaces. it is a kind of a delicious freedom, isn't it? To think of an architecture which has such compression and such a kind of stripped, empty space as being its ideal. I think that this relates to a much older tradition, in fact, the tradition of humanism itself, the tradition that says that outside the world of nature and of the kind of difficult world of human forms and of sentiments lives a kind of an eternal world of pure boundaries. Leonardo's famous Vitruvian human, this figure that Leonardo drew some 500 years ago, I think exemplifies this, the idea that what we try to do in some circles is take the messy business of organic reality with all of its circumstance and project a pure boundary around it. So the most important thing in this is the sense that something could be whole and bounded and absolutely distilled, as if the shell around us is the most important thing. And I think we can see that this way of making architecture, making space, can be extraordinarily effective in creating territory and clarity and truth and a very, very strong kind of beauty for those for whom are able to live within its boundaries, within its territories, because it polarizes space, making walls, making things as clean as possible. But of course, there are those who are also excluded in this way of making. It's beautiful for those who have the territory. It's not beautiful for those who do not have the territory. I want to ask if some different kinds of boundaries might be possible other than that sense of empty space and polarized boundaries. And so I found myself looking at some other depictions, such as the lovely kind of medieval qualities, late medieval qualities and early Renaissance qualities, in which halos are projected. And most certainly they still have absolutely pure individual concentric geometries rolling around them. And yet the sense that we could start to inhabit the zone outside our own bodies, inside the gentle and radiant realms of the hair of this Madonna, or perhaps of the brocade, or the broadcasting light, is something that I find very, very attractive. Here's another image of this lovely mandorla that is this feminine halo, lozenge-shaped, boat-shaped, in which the individual elements of rays of light really speak of a kind of a very gentle, fluctuating boundary in which the presence of this individual, this is Neri de' Bici, the painter painting in 1555 or so, and in this image of St. Catherine in the Christian pantheon. The sense is that rather than one single purely bounded figure, we have multiple bubbling layers, fluctuating layers, in which presence is felt across a whole scene. I love that sense of an expanded set of boundaries. And perhaps that relates to Giacometti's work as well, the sculptor that I was sharing before. I was emphasizing his sculpture as being full of empty space, but in fact, when we see this portrait of his mother, I think we can see that the innumerable touches in this filamentary network suggest that the space is actually redolent with all kinds of touches. And as we look more and more, I think we can start to see that there are beautiful examples of oscillating, involved, filamentary space. This is an earlier example from the Edo Gospels, from the Byzantine period, about 800 after the Common Era, in which this kind of oscillating, ecstatic, kind of trembling quality suggests that space has a very, very different quality than the kind of absolutely bounded, stable one that I was showing earlier. And so those qualities then are translated very directly into the kind of searches that the studio has for a kind of space which is filamentary and thickened and full of presence. What this suggests then is that the empty space that I was speaking before might need a different name entirely, because space does not need to be seen as empty. At least those examples from visual art suggest as much. Here's an image of space that perhaps might be a hint that we can draw our sources not merely from imagination, but also from fact. This is an image of the large Bolshoi simulation. Bolshoi means grand, enormous. And the large Bolshoi simulation is a collection of all known radio transmissions from the entire universe. This is a small sample of the entire simulation. And then it's rendered and arrayed and put together and then made visible. And what happens when all of that information is combined together? What do we see? Do I see the individual points with empty space between them? Do I see the randomness of an expanding universe? Do I get the sense that things are empty and silent? I'd be very curious about what your own reactions are to this image. I really can't apologize for my own reactions to it, in which I see this as the most kind of deliciously filamentary tissue-like substance that's utterly full and boiling and cellular and creating myriad forms which house me and which extend out into a coherent kind of continually fluxing or organic cellular accretion. And that sense that in space, there is this kind of structure, a fluxing tensile structure, gives, I think, such an extraordinarily different quality of thinking about what space is itself than the kind of emptiness that I was referring to earlier, the emptiness that was given, say, by the Hubble telescope, where we just see the points. We don't put them together. This is a digital model of the large Bolshoi simulation, where you can start to see it accumulate. It has a lovely subtlety to it, and seeing it in three-dimensional space helps, I believe. I love thinking about what this image of space is and what it offers and how it forms and how it's continuing to form. I love the sense of its presence. I love the sense that that kind of organization of multiple filamentary shifting cells can then be seen in many, many different places, kind of encouraged by the vocabulary that we can learn from looking at that kind of simulation. Right now, we're looking at the surface of the sun, boiling slowly, little patterns of darkness and brighter patterns of hot. And again, what seems remarkable to me is the extraordinarily coherent cellular matrix that we see here, in which a tissue-like filamentary network, a remarkably coherent kind of fabric, can be seen. And so this raises questions for me about what kind of response we might make to a world which is so very uncertain. I love the idea that we could start to make some boundaries that are profoundly inclusive, that could draw together the kind of relationships that I'm trying to evoke now in those materials. And that they could be really very confident, and that they could create a kind of collective architecture and fabric and sculpture, which really could draw together the kind of presence that I'm trying to evoke by those material examples. Let me go on by suggesting that this then can be very deliberately organized as a series of shells and boundaries for a sculpture and textile and architectural practice, by working very deliberately to make multiple shells of space and to organize them and to make them tangible and to seek to make them sensitive. Now, I hope that by giving some more examples, that slightly abstract intention can be made a bit more coherent. But what I do want to just emphasize is the agenda, the idea is to realize, is to help make transitional fields, is to help make it possible to feel a continuity so that our bodies are rendered open, and to allow them to have an experience, to allow us to have an experience of a kind of a delicious, interwoven, riddled kind of relationship with each other and with the world. So that rather than the kind of confusion or fear that might come from the sense of uncertainty about me being a part of you, or my feeling ambivalent and not knowing where I am, a whole other set of sensations might arrive. The kind of delicious, ironic quality of deliberately making yourself dizzy, or seeing the kind of irony in a situation in which things are riddled together. Now, I've been talking about perhaps an ethical quality in those little diagrams, but I want to emphasize that there are definitely ways to build up this sense of the washing back and forth by using computer modeling, by using digital fabrication and specific detailing, by working with tensile constructions, by working with fabric. So here's an example. Here's an example using ParaView, which is an open source computer modeling software used for predicting weather. This is computational fluid dynamics. What we see here is a kind of interchange, which is very, and there's a fluid material which is rolling in turbulence across the screen. But the kind of interchange that we see is very different than the kind of fearsome accumulations that happen, say, in a hurricane or a tsunami, or the rigid periodic systems that happen in traditional cymatics, C-Y-M-A-T-I-C-S, that is the kind of interference or resonance patterns where you have an absolutely stable kind of periodicity or periodic rhythmic form happening in the world. Instead, what we see in this is something which is quasi, that is intermediate, continually fluxing. The technical term for this is quasi-geostrophic turbulence. Sorry for that. Geostrophic, trophic meaning turning, geostrophic, the turning of the world. Quasi-geostrophic, the stuttering, partially oscillating qualities. And this is achieved by working with a fluid body so that it can shift and be plastic, and then imparting it with a couple of different nearly opposing forces. In this case, the Coriolis effect, spinning of turning, and planetary gravity, which is modeled into the simulation, which pulls it transverse to the Coriolis effect. And when those are nearly balanced, then we have this continual upwelling and shifting and upwelling and ceasing. And I love the way that it keeps on refreshing itself, a very gentle kind of shifting. Okay, so what I'm suggesting then is that I think that we could really benefit from a set of quite different terms, and that rather than speaking merely about empty space in the classical terms, that we could really use a medieval term like ether, the implication that space is full of presence. Or perhaps we could say the Higgs field, that is the wonderful discovery of the Higgs particle that occurred at CERN just a few years ago, in which mass is seen as arising continually. That in turn suggests that we might think of a set of different terms, such as rather than being concentrated on wall making and shells and boundaries, we could become very concerned with the manifold, with the many-chambered reticulum, and the reticulated structures and the interwoven structures that could make for continuous relationships. So what you can see is that I'm making a little manifesto in this introductory talk. I've used a lot of syllables. I apologize for those, but I hope that you can maybe share with me in conversation your own impression of this by saying that rather than concentrating on a shell like that image, that a very valuable project could be an alternative project in which we try to achieve the maximum amount of reaction face so that things are reactive as possible and they're as involved as possible and they reach as possible, as much as possible. So what I will suggest is that this can come directly from nature, such as the example of snowflakes, in which rather than something condensing and freezing and becoming as solid as possible, we can see that what's happening in this example of snowflakes forming is that the maximum possible reaction face is emerging as heat is being pulled out of this water material and making the most glorious kind of partial, multiple, different surfaces. The largest possible reaction face out of a given mass might be a definition of what a snowflake is. Very different than the kind of transcendental idea in which it's trying to make a perfect crystal. Rather, I think we can see it as being an expansive, vulnerable form, which is shedding its heat, dissipating its heat, and forming in dissipative adaptation. So let me take that cluster of thoughts and then apply them to a few projects. I hope it's okay if I speak for another few minutes before we take a break. In Aurora, a few years ago, we made many hundreds of elements that were designed to have the same kind of reactions as the snowflakes did. And here's an image of what Aurora was like. It was a bit like a swamp of many, many individual elements clustered together with a fairly rigorous geometry, creating clouds of material, held together resiliently using tensegrity systems, perhaps a little bit like the spider web that Marissa Belmurat talked to us about a few moments ago. And there's a web of many, many microprocessors running through this system, imparting individual actuators, kinetics, with the ability to flex and shift and clutch. And the sensation then is that when you move through it, an individual element will respond to you and ripple out. And then it will set up its own sets of ripples and move around you rather gently, not as a great machine, but rather similar to the sensation of being in a forest in which there's a kind of a resounding motion around you. In a more recent project, Meander, some of the shells of the sanctuaries and nests that I was describing here are starting to show. And so you can see a slightly expanded quality in this kind of environment compared to Aurora, in which it's not simply an ocean, but there are also some quite strong sanctuaries that are developed in the work as well. And this is based on individual cells, which are developed in ways that they have sensors, but then they take a stimulus and then they vibrate in response, or they recoil, or they push back, and they curl. And that kind of quality is imparted by using quite a deliberate way of designing and working with materials, so that materials are as fragile as possible and as compliant as possible. So they have a rather different agenda than trying to make themselves powerful. They're trying to be resonant. They're trying to be disturbed. They're trying to be precarious. Here you can see some of the scaffolds that make this possible. A rather deliberate set of individual cells that are woven together using quite rhythmic, methodical ways of combining elements in space, making space trusses and canopies, and then multiplying them and connecting them together using arterials. The overall system is really one of making laceworks and then stretching them through space, and then occasionally winding them together and making very, very dense shells and accretions that come together to make quite intense grottos and nests as well. And here you can see some of the qualities, if you come close, of how many, many elements are multiplied together into something that starts to oscillate, glitter. The individual clouds of material are woven together and clipped together so that they're individual cells that have resilient connections between them. And then very often they're amplified by the actions of light, by putting in vessels which are filled with liquid, which act as lenses, which then collect light and pull the eye through. And some of them are filled with protocell formulas as well, synthetic cells, which are showing just the very beginnings of the kind of mineral accretions and exchanges that natural living cells also show. I hope you can see some of the kind of rather gentle accretive quality of what happens when all of the cellular materials are shown. And then in turn, these are organized in patterns of vibration and patterns of light and motion. They're organized by using some custom software that colleagues in the studio are building, so that there's a meshwork of a possibility space within which the individual sculptural figures sit. And within the geometry of that meshwork, individual elements will travel and shift and flux and move and arise. And what's being attempted in this is not so much kind of a hurricane of force or flashing or major effects, but rather a very deliberate precarity, very similar to the quasi-geostrophic condition that I was showing in the model earlier. The idea that if we have multiple opposing balances pushing and pulling together, then individual elements can gently fluctuate and produce an extraordinarily charged, gentle quality of response. Custom software is built which allows the individual environments to be simulated and maintain themselves together with layers of firmware which organize how a given sensor reacts and how a given mechanism will react in a whole set of predetermined scripts that work together with the internal simulation. And here you can, that's a distortion, so I won't ask you to look at that one, but if that weren't distorted, you'd be able to see the simulation working together with the actual sculpture. Sorry about that. But I think you can see some of the behavior here in this image, where you can see flickering across the surface of the individual denser rays, kind of a storm-like an environment. Okay, so I'll start to wrap up then. What I've tried to describe is a sense in which space can be very, very much shared and partial, so that rather than trying to assert our own space, the space that's empty, the space that's just for us, we really can have a sense of being very, very deeply connected to multiple things all around us. And I hope that gives us some confidence in the kind of qualities that I hope the individual elements that maybe the design exercise that we're going to go on might have as well. That it's a sense that by working with cellular accretions, we can try to create things that are as reactive as possible. So I'll just stop sharing. And I hope that gives a sense of some of the qualities that we're going to be talking about over the next couple of days. Maybe before we shift to Lisa's presentation, I'd really welcome questions if you have any comments. Marissa Belmurat, you're muted.
I have a dog who likes to bark, so that's why I mute while I'm listening. The question that I had at a certain point is, how do you differentiate between reactive and interactive in the scale of what we've been looking at?
That's a really hard question.
Then don't answer it, but it is a question. You don't have to, to my mind, as I was looking, I was thinking, is this a reactive relationship, and what would make it interactive relationship? Because then somehow something must transform on both ends, right? And so that's really gotten a lot to do with some of the stuff that I am interested in too. And it's just a question that I want to throw out into the space of how we define or how we differentiate, or is it phases that are kind of perceptible at certain scales and at other scales not so perceptible?
I wonder if I can just tackle that in a couple of layers. That is to say, starting with reactive and going to interactive. Maybe we could say that there's a fundamental problem in the world in the sense that very often we don't have a feeling of agency. It's very possible that we have a sense of being pushed around and having a loss of self in just the enormity of what is accumulated in the world today, in the way economies have taken off and have started to feel mechanical, in the way the climate has accumulated and become so inhospitable and so utterly frightening. So that would suggest that there's all kinds of things that are pushing and pulling, and we might react to them, but that doesn't give much of a sense of fundamental emplacement. So what would an alternative be? Well, I think we could certainly say that what we might hope for is a mutual relationship.
Right. Yeah.
Mutual meaning that I'm not on top, you're not on top. We care about each other, and nor is the human species on top of other things, but rather living in harmony with. And that means a continual set of negotiations and any amount of compromise, which might very well be frustrating, but not terrifying, surely, if a sense that mutuality really is possible. Now, if that's a general ethical sense, if we search for mutual relations, then interactive might be a term that we build as a quality in architecture and sculpture and fashion alike, as being the kind of material equivalence of mutual relationships. so that rather than me being the agent who simply pushes around inert material and has my way continually in the empty space of the world, there can be much more of a sense of a negotiation where I can be alive and it can be satisfying, and it's not a struggle, and yet there is a pushback. There is a sense of the consequences of what I do. And perhaps somehow that sense of negotiation could be a delicious one rather than a frustrating one or a frightening one. So interactive is a very provocative term. Now, in turn, I would say that the term can be a problem because interactive might imply that what we're talking about is, okay, so I have me, we have you, and we have somebody else, and each one needs to be their own closed body in order to get to the politics of how we are going to negotiate. And
So it's still reactive at some point in that sense.
yeah, it is. And it still might imply the kind of empty space that I was complaining about at the beginning. It's still, in fact, I think it still does that, you know, in a reductive model of what's raised with interactivity might be, you know, billiard balls,
Right.
in a really negative sense. I'm very attracted to the idea of intraactive. I mean, if we take inter and just reverse the lettering and make it INTRA, then intraactive means, intra means it's within yourself, like intramural means within the walls, right? You know, when we were kids, we had intramural sports, which meant that it was within the school. It wasn't just like schools competing outside. It was that we could be working with ourselves and within our own families, and within our own bodies. So intraactive seems to be a term, incidentally, that's Karen Barad talking, a wonderful, beautiful queer physicist who I really adore, who speaks about intraactivity as being a model in which what we do is we recognize that our own materiality is bodying itself forth and making ripples in the world, and that there simply is no attempt to separate ourselves from the world. There's much more of a sense of material justice in which things are affected, and what we do matters, and things wash through us, and we try to see how that happens. Now, that ends up being a riddle as soon as we move into questions of, well, in order to do something, I have to kill. In order to do something, something has to cost something. And if we have those models in us, then we end up with riddles and challenges. But I think the attitude is there, in which we can see sometimes that we actually deliberately make ourselves dizzy and roll down a hill. And very often when we're ambivalent, when we don't know, it's because it's genuinely that we're pushing and pulling. And if there can be somehow a sense of levity in that, then I think that we're off to a pretty good start. In other words, what I've tried to do here is give some material examples in which it doesn't have to be so polarized as only a tough shell,
Right.
or only a spider's web. We can have things like this instead, you know, like where something is maybe soft and you can squish it, but it will hold up pretty well as well. And you know, like there are craft objects which can start to offer a kind of an architecture, I think, which are really very encouraging. And so it's precisely that body of resilient material, demonstrating that it can be quite tenacious, quite tough, that I think that Lisa and I want to offer in this workshop. That was a rather long answer.
No, that was a great answer. Thank you. Thank you very much.
A few colleagues have joined us during the talk, and welcome. I'm so glad to see you, Roshni Anand.
I apologize for the delay in joining.
That's okay. The beginning of this session is being recorded, And so we'll put the recording up so you'll be able to see the portion that you weren't able to hear. What I did want to ask each of you to do is just to give a very brief word of introduction, and then we're going to shift to Lisa's talk very, very shortly. Maybe Victoria, Hanan, and Roshni. So just give a couple of words on who you are and where you've come from.
Perfect. I can start. Thank you very much, first of all, for the talk. And sorry for my delay. I'm Victoria, but you can all call me Vicky. I'm from Germany, live in Hamburg, not Hamburg, Berlin. Sorry, I moved here already. And yeah, I'm studying architecture, and I'm doing my master's at the TU Berlin. Before that, I was studying biodigital architecture in Spain. And there I first got in contact with you, Philip Beesley, and even got very curious about your work. And this is why I'm here.
Welcome, Victoria. Thank you.
Thank you very much.
Roshni.
Hi, my name is Roshni. I'm from India, Bangalore in India. I'm an architect by profession, and I have pursued my Master of Architecture from the Architectural Association School of Architecture in London. And I pursued the course, the Design Research Laboratory. And I have had a brief interaction with you, Philip, so at the DigitalFUTURES Young Interactive Design, where you were the moderator. So I have been fascinated by your work, and that's why I'm here to learn more about your work.
Nice to see you again, Roshni. Thank you.
Thank you.
Hi, Hanan.
Hi, I'm Hannah Wolfe. I'm a assistant professor of computer science at Colby College in Maine. My PhD is in media arts and technology from UCSB, and I think, Philip, you gave a talk there like years ago, and that's kind of where I first heard of your work. And yeah, so I build interactive sculpture as kind of my research focus.
Well, I'm so glad that you're with us. Now,
actually, I had one question. What times does the workshop start? What's the current scheduled time?
So it starts at 10 a.m. EST, Eastern Standard Time.
Okay, because I think on the website it might have said Central.
Yes, it
Central
did.
time.
Oh,
so that's
wow.
why I showed up at 11 EST.
Oh, I'm so sorry.
Okay, yeah. So that's I'll make sure to be here at the right time for the rest of the week. Thank you.
Oh, wow.
I meant to
All right.
mention that it was on the website at 11.
Wow.
Eastern, and then your email this morning I noticed said 10, and so the Zoom call. So
Okay.
yeah.
That explains a lot, and I'm so sorry. Is it okay if we do hold to 10 a.m. to 12:30 Eastern Standard Time? Okay. Well, thank you. I do apologize for that. Now, colleagues that have just joined, we were speaking about Basecamp, which is the place where we'll be messaging and sharing material. And also on Basecamp, you should now see a Miro link. Miro being the collective pasteboard. And those of you that didn't hear the discussion of the charrette that we're launching, I'm going to suggest that maybe you stay for a few minutes just at the end of this session, and we can get you a bit more oriented. The notes that are on Basecamp that talk about the design exercise are pretty self-explanatory. That is asking you to get a couple of 100 elements and put them together and make a fabric today. And then we're going to talk about the qualities that you found in them, and then we're going to start developing them more and develop it into a piece of couture or a personal architecture by the end of this week. So I hope that'll be a really pleasurable charrette, and that will be both in terms of making physical elements and photographing them and pasting those up to share them, and also in diagramming and modeling, really using material that you're comfortable with. Okay, Lisa, is this a good time to move over to you? No, because time's a little short, I hope it's okay if we don't take a break and if we keep going. Is that okay with everyone? It's a bit of a long session, but it's just such precious time to share together. Lisa, the floor is yours.
Hi, so I'm just going to share my screen and start up a PowerPoint presentation. Can you see the PowerPoint now?
Yes.
Great. Okay, so I'm gonna do a short presentation focusing on the collaboration between Iris van Herpen and Philip Beesley Studio, starting with this really beautiful project from a few years ago now. I think this is one of the first collaborations that they worked on together, which uses miniaturized spars to create the two dresses surrounding the central figure in this first image. So going to the large scale sculpture to start, you can see this is a sculpture that we installed in Gaslight Meander Tapestry Hall in Cambridge. It was a 2019 install. It was my first install at Philips Studio. And yeah, some of the large scale structures that we can create using this component that's known as a spar. So the spar component is cut as a flat sheet of acrylic or metal, and it's then thermoformed or pulled using a lot of force for the metal to create this extended shape. And you can see two different scales on the screen right now, the architectural scale and the miniaturized fabric scale. And I think one of the particularly interesting things about that is the different connection details that are used between those scales, because the spar miniaturizes, and for the architectural scale, we've been using nuts and bolts to hold it together, and it gives it a very rigid shell form. So you're able to create this really beautiful geometric sphere shape. And then when it's translated into fabric, to give it a more drapable quality so that it moves with the body, we started using these small silicon connectors. So if you look in detail, the pins are made out of silicon, and there's also a very small tri-connector between the spars that it's also made out of silicon. And it's that connection detailing that gives the architectural spar unit its fabric-like quality. So you can see a little bit more about how you can drape and handle the fabric in this photo. And this is just a little plan and section diagram of the spar cut files. They're based on a hexagon base grid. And then, so when we tessellate together, it's kind of like a honeycomb tessellation, a continuous honeycomb tessellation. And you can see on the screen two different sizes, the 300 millimeter and the 150 millimeter spars, which are both the architectural scale. It refers to the base grid that the spar sits on, that dimension. And you can also see how you can achieve like the long spars and the short spars by editing the cut file. So the long spars I really love because it directly relates to zero waste pattern cutting, in that you use like the whole sheet of the spar, you cut out the slits, and then you create the extension in 3D space from this zero waste cut file. And then the short spars are a development of that, where you start windowing out areas, you create less filaments, and then you get less extension. And then the short spars in particular are the cut files that we miniaturized and developed into fabric samples, just because the height range that the short spar can give is really nice in relation to the body. That's kind of been our area of focus. So the short spar cut file here starts to become very close to what was adapted to turn into some of the Iris Van Herpen and Philip Beesley fabric collaborations. And then, so this was a later season, a development on the same idea. This was Aeriform 2017 collection. It was a really nice collaboration between the two studios. I was working at the time as an intern at Iris's studio. This was when I first met Philip also. And the shape that was created built on the spar cut profile, but instead of molding it by pulling and extending, which creates like the point, we used domes, so moldable jigs that pushed it into this dome shape. And they're also much more windowed than what we've seen before. And this is some of the images from the photo shoot from that collection. Yeah, it's so nice. The whole dress is made out of metal, but the overall quality that it gives is so delicate and airy. And in terms of connection details for this dress, you can see a lot of it is cut out from one sheet, and then it's formed after that into the domes. But then we also used, heat shrink tubing after the fact to start building out in even more 3D to give a halo around her body. Yeah, just to like start branching out even more from the base on her body. And then this image shows that same dress from the Aeriform collection exhibited at the ROM in combination with installation by Philip. And I think that this, yeah, it's a really nice example of the relationship and the dynamics between architecture and fashion. And it just emphasizes the idea that both disciplines kind of are so built around the body. So fashion is like a closer relationship to the body, and then architecture creates a larger environment around. But it's so clear in this image how both of them are like strongly related. Everything is dimensioned off the human body. And also I love the way that the dress and the sculpture just speak to each other visually also. But yeah, it's like the idea of building out expanding cowls and shells around the body that we wanted to explore further in this workshop together. So the next project that I wanted to talk about was this dress. I think Philip also had an image of this dress in his presentation. It's from Sensory Seas, and it's one of our more recent collaborations with Iris's studio. This was my first project that I worked on collaboratively when I started at Philip's studio. So like after my time working at Iris's, I moved to Philip's, and in the first few months we started, when I started at Philip's, we were developing this fabric technique. I think, yeah, it's one of my favorites of the collaborations that we've worked on together that I've personally been involved in. And the idea was to create, this is made out of like hundreds of layers of fabric that are stacked together and connected with chevron pieces, and the chevrons alternate so that it opens up into this concertina. And what we wanted to do was create a really drapable sculptural form that could like twist and form around the body. And so we started initially with 3D forms in Rhino that then you slice like a loaf of bread, and then you get the laser cut profiles to create the fabric. This is one of the very early samples that we created as part of the process. This is not the final fabric that we used, but you can already see how much it can transform. This is when it's fully compressed. Yeah, I was surprised actually how tall it is still when it's fully compressed, because the height of the chevrons adds up so much. This is, I think this sample is already like 90 layers. The final dress had, I think, maybe 500 in total. And we started also in the development process, we were looking at different options. So as well as the solid shapes that we sliced through, we were looking at foams and like punching holes through. This one is much more geometric and hexagonal, and it was an earlier prototype actually where we were using glue to connect the pieces together, just to like think through the process of how we could connect these layers to create the concertina effect. And then we moved on to the chevrons. This is another exploration in the idea of a foam expandable mesh. And that's it when it's compressed. And then, so we started moving into the development of the final cut profile for the garment. And this particular sample focuses, like the top is recognizable already from the earlier samples, and then Iris wanted us to really pull out the bottom of it into a drapable fabric. So the bottom, there's only a small portion of it that's actually connected with the chevrons, and then the rest of it is free to like flow and drape into the skirt of the dress. So yeah, this one, we sent them this sample, and it actually ended up in the shoulder of the final dress, which was exciting. This is the final dress. The top of the dress ended up being laser cut here in Toronto, and the bottom of the dress they cut by hand, which is a terrifying. But apparently the laser cutting of that many layers is too expensive, and instead they just sent it with little scissors and hours and hours of work. But that's the final dress, and this is the dress in movement in the picture. Yeah, I think I really like the way that it moves at the bottom compared to the structural quality it has at the top. Like the neck has always kind of amazed me. I asked them when I saw it in real life how it had stood up, and I really think they said that it was just the structure of the fabric that's giving the shape of that neck, which is amazing. Like the same fabric, you can have such like a drapey quality at the bottom and like such a sculptural structural shape at the top. And then the last fabric exploration I wanted to talk about is this fabric that's called the glitch fabric, which has been also developed over several collections. This one is an image from Aeriform collection again. The glitch fabric is another zero waste pattern cutting technique. So you can see the cut file of the glitch is when it's fully closed, is just alternating slits, curved slits in the fabric. And then what I really like about it, I love the sleeves on this dress. And again, it's like the shape and volume that you can create just from like cutting out a particular laser cut pattern on a flat sheet of fabric, and then its relationship around the body and its relationship with gravity and its elasticity and stuff like that creates this like really beautiful 3D silhouette around the body. And then you can see the development of the this is a different collection, the two looks that we're seeing on the screen now, the development into print and other combinations of fabrics for the glitch pattern. What I also like is how it reacts with the later collections, how the glitch laser cut file reacts with the print file. And when the model is still and the fabric is like closed on her body, the print file reads a lot more. And then when she's walking, the print opens and it kind of gets a little bit more focused on the laser cut and the drape and fall of the fabric. You can see the laser cut pattern much more. So it's like a play between those two different visual languages. And so this is, again, a little bit more process of the creation of one of the glitch dresses in our Toronto studio. This particular dress, the process behind this dress was quite amazing because, my recollection of it is from Amsterdam, and we had just a lot of coordination to do and a lot of like perfect alignment to make this particular dress work, because it's made out of transparent mylar that's then heat bonded to black foil and then laser cut after that. So every stage had to be carefully aligned. And so it started in Amsterdam, and then it got sent out to Romania for the first stage of laser cutting. It came back to Amsterdam. The heat foil was bonded onto the transparent mylar, and it got sent to Toronto. And the second stage of laser cutting happened there, sent back to Amsterdam to get assembled into a dress, and then to Paris for the show. So this one went all over the world, and it was so stressful. Like every stage, we were like, if this doesn't align, the whole situation is going to be for nothing. But it went really well. I love this particular one. It turned out so like ethereal and beautiful. And then again, a little video of the glitch in movement for the red dress. And then I just wanted to finish off with a few other collaborative projects. This was a Iris Van Herpen photo shoot with Tim Walker and the artist David Altmai. And I wanted to show them because it follows on from the idea that we wanted to explore of fashion and architecture as shells that grow out from the body. So I love the relationship here between the artwork and the garment. And in this image also, just the relationship that is explored between sculpture and fashion and the model. And this collaboration, which was between the sculptor Anthony Howe and Iris Van Herpen, is again another example of the cowls and shells around the body. And what I love about like the direct visual relationship between the sculpture and the dress really makes it feel like the dress is like being born from the sculpture, or that the sculpture is growing out from the dress, like the different ways that the architectural scale and the fashion design scale feed into each other. That's it. That's the end of my presentation.
Lisa, I'm just going to go and grab a couple of samples of the glitch fabric, just so we can share that a bit more.
Yeah, for sure.
Lisa, I'll ask you to chime in as well to clarify how this is made, but I thought that it might be useful. So I hope that what you can see is a basic cutting pattern in which there's very simply, a repeating line which overlaps, so that if one line is in a fixed dimension, then the next line is in the opposing dimension, just like a running bond in brickwork. Can you picture that? And then in this case, that basic kind of slitting pattern then is simply warped, but the same thing is happening. It's just that the line is warped. So do you see that second stage of derivation? Can you picture how that's made? Now, there is also the sheer fineness of this. This is quite carefully controlled laser cutting. We've kind of like taken this to a pretty intense point, empirically, just really trying to understand the limit of, okay, well, how fine could it be, and just how thin it could be. And I want to come back to that because it's not just to be extraordinarily fine or extraordinarily exotic, but it's rather purposeful to get to that limit state. But let's just see what it does first of all. Here's the geometry, and then when it pulls out like this, what you can see is that in three-dimensional space, a ripple develops. See how that works? And so that's derived from the stretch and the displacement of each acting on the next, and that's rather nice, I think. I must say I'm really very, very fond of just that simple act. This is mylar, by the way, which is a biaxially oriented polyester. That's the polymer. It's a very stable one. Now, the other thing that I want to mention is just the sense in which this moves, and I wonder if we can just see that in terms of, if I move my hand here, do you see how there's a rebound in which that motion goes to here, and then to here, and then to here, as if it's a pebble in a pond moving across a screen? That's that sense in which one motion is shared and carried and moves continually back and forth, I think is really a very worthwhile one to keep in mind. The sense that if you have a meshwork of many linked elements, then we can start to have a set of relationships that is not simply one which is monolithic, in which the entire crystal simply moves and the force immediately transposes to the next side. That's what happens in glass or other vitrified crystalline elements. But in resilient systems, a couple of different things happen. If something is completely compliant and resilient, and it's just made of many, many things, then what we get is damping, the kind of absorbing of force. Think of, for example, the beautiful swamp at the edge of a meandering river, and the way storm water would just be absorbed by the edges of all of that kind of floating matter, the sedges and vines and root matters that would be the edge of a wetlands, produces an incredible resilience, which is a damping and absorbing. Now, that may or may not be a positive quality in an architectural or fabric sense. I mean, perhaps we don't want it just to completely absorb and deaden everything. In the case of something like felt, where there's many, many individual fibers, each one of which is compliant, then we do have an extraordinary kind of damping, which is extraordinarily beautiful, but it also is it's its own kind of inertness, acting a little bit like the way soil works. It's a damper. This material, on the other hand, is interlinked, but it's quite stiff as well, and it's got a liveliness to it. And so what happens is that each of these filaments shimmers and vibrates, and then also passes on some of its energy to the next. And so that what happens then is a very different kind of set of relationships rather than just pure damping. And so that's what we were really after here, was was the quality of trying to make this live. Now I'm just going to move this with one layer against the other, and I'm not sure whether the resolution of the camera will show this or not. But what I hope is that you'll be able to imagine also that there's a moire that happens, that is multiple interference patterns where one layer works with another. And so I don't think that the camera will show it, but I'll just ask you to take it for granted that there is in fact a moire, meaning that the interference patterns between the different gridworks also produce a kind of visual oscillation. So the complex that results in then is a combination of the physical shimmering that results from this pebble in a pond kind of phenomena, together with the pathfinding neurology of our own perception, in which we are seeing different thickenings optically, and we're chasing those neurally in our own brains as well. And so it's a combination of what's physically happening together with our own perceptions that produces quite a lively kind of system. And I'll just show you one other one which we didn't ultimately use in the end, but this was where we felt that the filament was so intense that it needed some visual contrast. And I'll just put this into tension by twisting it. And then I hope that you'll be able to see the development then of the individual ripples and then the way they play together. Now, there certainly is some moire happening in that now, and I hope you can see that in space. So I wonder whether that's an okay thing to emphasize the idea that what's going on here is, yeah, the moire is quite strong now, at least it's on my camera. Can some of you see moire happening?
Yeah, you can see it, Philip.
Okay, I'm glad. Well, I wonder whether it's okay to emphasize that this is in part a perceptual play, playing with our own perception, and in part a very, very physical kind of experience. Let me say just one more thing about taking something to a limit then. What happens when these are cut so fine that they just about burn up and the machine just about wobbles and it just about falls apart? Well, I mean, you could say, okay, that just makes for a nightmare of quality control, and it makes it, really awful, and it makes it way more expensive than just a privileged game. There's something else that can happen as well, though, in the sense that an agenda of forming a fabric or of material could be to unlock its reactivity and its liveliness. And some very, very interesting things start to happen when you take something and you cut it and you form it just so that it's close to its ability to span. Now here, what you can see is that as I raise this up and hold it, it becomes increasingly difficult to hold it still as it's cantilevered out. And every little tremble of my hand seems to amplify it. I really love that sense that there could be a way of making things which are very deliberately amplifiers for subtlety, harvesting the kind of resonance that happens at the edges of things and greatly spreading them out. And I think that's very much on a practical level how our sense organs work, and certainly how, say, an antenna works in an insect's world, in which something is greatly stretched out and collects resonance and then makes it possible to have a conversation with the unseen dimensions and the extracorporeal dimensions of our world. So I really love the sense then that by taking something close to a precarious state, deliberately kind of seeking precarity, then it becomes possible for something to be unapologetically vulnerable and lively and full of resonance and full of expression. Now that's clearly a different kind of design ethic than the one that makes one of those, you know, pure things, tough things, as pure as possible. To make something which is deliberately precarious instead is somehow to have the agenda of embracing what the world gives us, as opposed to asserting and making something strong and clear. And perhaps that's one of the, maybe the speculations that was in the earlier talk today, which is that rather than a design ethic needing to have the kind of humanist tradition of making something as clear and pure and true and reliable as possible, perhaps there really is some very practical craft in making things sensitive, trembling, open, ambivalent, that could be very, very effective. Now, we can have other talks about how that's also a source of sustainability and a source of resilience, and a great way to work with polarizing forces that can reconcile them, a great way to work politically as well. I mean, I personally do believe all those things, but I think we need some other material to kind of build up those arguments. But perhaps this is a helpful way to start, to talk about the sheer craft of it. And so this is an invitation then for you to, as you work with the cellular accretions, the fabrics that you're asked to play with and to build for the rest of your day today, and to gather for the beginning of the workshop session tomorrow, and to photograph and to put on Miro, I'd like to ask you to have a rather particular agenda. Try to make them as expressive and resilient as possible. Try to make them as precarious as possible. That'll probably require that you go through a couple of generations. Because first of all, just the sheer coherence of something is necessary, right? Something can't be precarious if it just falls down and it's shattered and it's chaotic. It needs to have a certain coherence so that then the behavior of whether it's going to tip one way or the other is unpredictable. If it's merely just a tangled mass, that's not predictable. That's not unpredictable. That's predictable. And it turns into a kind of a damping matrix instead of a precarious one. Try to see if you can fasten things together and find a kind of a lively combination which has qualities of precarity. Does that terminology make sense? So Ed, we have just a few minutes left in today's session, and really welcome your questions, especially for Lisa, who was directly designing the dresses that you saw in the runway work.
Yeah, I have a question for Lisa. First of all, thank you very much for showing your work. I would like to know how your form finding process looks like. Are you first designing the fabrics and then the forms, or is it happening simultaneously? How do you design the dresses?
Victoria, so I think the question is, what's the design process for these particular forms to come into being? That's a good, strong question. Lisa, do you have your notebooks handy? And do you have samples at your desk? I can put up a few of mine as well. I've got a notebook here, so I'm going to show some. I'm just going to search for a couple of formative things here.
I think in terms of the design process, for me, personally, in my own work, it's a back and forth between the fabric development and the overall silhouette. Like they both inform each other. And I think it's the same for Iris's studio also. What I did see was that, because I was there for a few seasons, that the first month after the show is a really nice time for exploration and creation of new fabric samples. So there was definitely like a phase there where they spend like a month and you just have a play with all the ideas that have been like built, because like there's a phase of production just before the show and you're just making the final dresses. Everybody knows exactly what they're doing. They're trying to meet the deadline. So directly after the show, all those ideas that have been like coming up in the meantime for new fabric ideas, there's a little bit of time to explore that and make samples. And then when I was working at Iris's, I guess from that first month of exploration and experimentation with the samples, it then went through to design phase on Photoshop and hand sketching and draping on the mannequin with those fabric samples. And then it would have to go back to the fabric sampling phase for refinement, like how it would work as a sleeve, how the side seam is integrated into the fabric sample, like how much strength we need to add to it so that it can hold the whole silhouette that we're trying to design. And then like pattern cutting, for example, pattern cutting is informed by the silhouette and shape of the fabric sample. Like with the particular curves that are cut out into the pattern cutting are informed by the sample. And then again, there's like a lot of back and forth in the refinement stage, so that the shape and the techniques are well married together. Yeah, that's it.
I wonder if I could just add to that with some examples of sketching from those different stages. These are a few pages of from a recent notebook of just a couple of weeks ago. But here you can see very, very elemental relationships being built up. Okay, we work from a shell, then we exfoliate and make that centripetal. Then we aggregate those together, and then we put those into formations so that then there's some daughter and parent and turbulent elements, and then there's a point of sort of kissing just between two individual cells. So let's say that that's kind of like a primary, almost elemental politic, and then that becomes studied as a sense of relationships in worlds where your scale and then the membranes and the reticulations billow out. And so things can really flatline if we just talk about generically about billowing or turbulence, but if you build those up with very, very specific kind of fabric topologies, they become really coherent. And so, for example, we were studying close packing tessellation here, where you can see individual cells and interstitial elements between them to build up a very particular kind of fabric that would start oscillating. And then that turned into a sense of, okay, we're actually going to turn that, and we're going to make it chiral. We made this decision to turn each one of those elements so that then there would be a water wheel kind of approach of having each one of those elements interlock into the next. And that made us start to think about, okay, what kind of are the actual elements? And so here you can see some prototype petals with a number of solid and void patterns. And I hope that you can see something a little bit happening like the glitch, in which there are alternating openings that make a structured foam. And then that turns into some quite rigorous elements in which, okay, we're going to stretch that foam piece on a bow and it's going to be on a printed element, which is cut like this. And here's a printed circuit board that's going to be strung on that, and we're going to push it back and forth. So this kind of constant back and forth between like absolute primary geometries. Here is a hexagonal or triangulated element, or here's the tessellation geometry, back and forth with the industrial design systems of those. That represents a kind of design space. Now when I've just shown you hand drawings, but there's a constant back and forth with physical models and digital models as well. So all three of those things, both the kind of intuition of thinking that goes into handwork, and then the kind of intensity that can come from radical compounding in virtual space using computational modeling, and then the sheer kind of listening from the physical world that happens from playing, and just discovering. I would say that all three of those kind of actions have slightly different vectors, and I think all three of them are absolutely essential, and so they tend to go in many cycles. Lisa, you had a few more samples to show.
Yeah, so this is just some of the samples that were developed from the sketches in Philip's sketchbook. So you can see the front development. A sketch was shown in Philip's sketchbook of these, and a different material that we've been experimenting. This is in organza and mylar. This one is pure mylar, to create different vibration effects. This one is one of the industrial design details that he showed for an actuated component in the sculpture. So it clips the front, this mylar leaf clips into the acrylic stalk. And then this one is one of the smallest spheres that we've made in relation to like the idea of the sphere clustering that he showed in his sketches. So we're aiming to build more of these and cluster them together for one of our new upcoming sculptures, to create a field or a nest for the viewer to occupy. And the dressing, this is not size matched, but dressing for a larger sphere. Yeah, that's it. Just some of the physical examples of what was drawn in Philip's book.
What Lisa just showed is also an example of where something condenses and becomes more solid, and then opens up and becomes more of a hovering veil, and then condenses as well. I mean, there tend to be really kind of like a wobbling back and forth between those states, into more compression or more tension, more density, less density. And I have a feeling that that's a way of keeping things quite fresh, because things tend to flatline and they get damped and they start to become homogeneous if there's just one extraordinary intensity that happens. But it's really kind of like a delicious experience when things keep on rolling and oscillating and moving back and forth. What I've just done is I put into the chat a couple of minutes ago a couple of terms that might be interesting to check out, coming out of something like the glitch dress. And I have a feeling that it might be a way into understanding etheric space, not just as a kind of a homily or an ethic, but actually as a real physical kind of reality. Like, could ether be a real thing, the kind of continually refreshing presence in which we're deeply, deeply immersed? So I put in just one more term, Hesacastic Prayer, which is a medieval practice in early Christianity. A Hesacastic Prayer is a prayer in which the prayer is not verbal, but rather it's breath-based, and where the significance of the breath is so acutely felt that it's an encounter with the world and with unconditional presence outside of yourself. And because of the nature of your own metabolism, it moves in and out, and it carries itself, and it becomes a rhythm, and an oscillating rhythm. And so this sense of this kind of bubbling kind of like, it certainly isn't something that you are controlling yourself. On the contrary, it's something that rides you like ocean waves ride you, moving through you. And I have a feeling that kind of physical experience is quite tangible and might be relevant to the kind of significance or the potential expressive power of some of these fabrics. So I hope that kind of draws together some of the material from the lecture with some of these material studies. Well, folks, it's getting to the end of the session for today, and if anyone would like to stay on for a couple of minutes, that was joining late, just so we can talk about the charrette process, that would be completely welcome. Are there any other wrap-up comments that anyone would like to make before we do break? Any questions at all?
I had a question regarding perhaps the assembly of these dresses. I'm sure it must be quite challenging contrary to just making a conventional dress. And I think from one of the images you showed us, the one that probably went from Amsterdam to various other places, would it possibly be sent as segments and assembled on the model, or do you have a specific way of assembly? I'm just curious about these different dresses.
Usually it's shipped in pieces for sure, but assembled on the mannequin, because the amount of time for assembly doesn't, like a model would not usually stand there for days while we stitch it together. Like I think for the fabric, like the fabric panels as well, they start off for a long time on the table as flat panels. Like it's like when you cut out a pattern piece in fabric, like in a printed fabric or a jacquard or something, it stays on the table while you're cutting it. And the irises, the amount of time that it stays flat as a panel like that is much longer, because they are developing the whole 3D textile on the flat as a panel, and then it gets stitched together in 3D on the model. If that on the mannequin, sorry. Yeah, it helps. And then there are fittings usually, which are quite like intense stays, where all of the dresses that are ready go onto a real model, just to see how it is in movement and stuff like that. And then alterations are made after that. But it's usually just like one day and then back onto the mannequin or back onto the table.
Thank you.
Maybe the term moulaging would be helpful. Moulaging is a term that Iris taught me, in which different patterns and patches are drawn together with the kind of freedom of collage, but listening really carefully to the drape, or materially, metaphorically listening, watching, feeling the action of draping, and at the same time, constantly going back and forth and testing how it wraps around the skin and how it feels and how you inhabit it. And so you really are trying to inhabit a kind of a tipping point where your own body is at the edge of expanded, quite delicate states. I mean, like as if we're continually in a bubble bath, let's say, that kind of boiling off, shifting, liminal kind of quality. And it's that kind of expanded state of possibility then that results in particular things being condensed and resulting in the pattern making. Quite a lot of material gets discarded, to be frank, and condensed and reinforced. And then the choices of making things hang together and be coherent is is a very interesting one because it doesn't come at the beginning. It's like it's like the thickening and the coherence gets condensed and gets found as a result of a more open process. In the show that some of you may be interested to see in just a very few days, it'll be it's July 4th or 5th. Is that right? That right, Lisa? Remind me.
Monday, July 4th.
Thank you.
I was on mute.
At about noon Paris time. You'll see, I hope that these talks will help help guide or help you see some of the process or imagine some of the process, because there's going to be some quite complex new filamentary deep in meshed figures that you'll see there, and they have some of that quality of being condensed partially, but really expanding and almost evaporating in other qualities as well. And so I hope, Roshni, that starts to illustrate some of the process. So it's most certainly traditional pattern making, expanding it, moulaging and collaging, and then consolidating as well. Okay, folks. Well, thank you so very much for a wonderful first day. It's really wonderful to see you, and you know, thanks for sharing your own images on camera. It's lovely sense of connection. It's really a kind of a tangible sense of connection with you that results from you being willing to be on screen this way. So thank you so very much for that, and huge thanks to my colleague Lisa as well for that fantastic look. And Virginia for standing by us and helping us get this going. So let me just suggest I'll stay online for a few minutes if anyone would like to ask just two practical questions for the ongoing charrette, or otherwise we'll see you tomorrow at 10 a.m. EST. Isabel, you're muted.
I have a question about for tomorrow. I know that Moreau, you sent a link on Moreau and that appears to be working. So you want us to basically upload images of their sketches and anything of basically what we've generated in the interim.
Yes, please. What I'd like you to do is
and by when, so you have a
Okay.
chance to look at it.
So please upload it by let's say 9:30 a.m. It's your call about when you work, but just to allow about half an hour. And I'm going to ask you to make your own islands of material within the Miro space, and put your name on that island rather prominently, if you don't mind, at the upper left, just so that you can have your own identity, and you can anticipate that you're going to be building and expanding day by day within that space. So everyone's going to be in one complete space, but think of each one of your clusters as having an island.
Yeah.
Makes sense.
Yes.
Don't hesitate to put up inspirations as well, please. Images that you're interested in, as well as the material that you're making yourself. We can say a little bit more about that tomorrow, but I'll really encourage you to make it a sketching space for this dissipative, maximum reaction, maximum precarity fabric of at least a couple of hundred elements. Okay, great. Thank you so much for today. Take care. Hey, Hanan, Roshni, Victoria. So, would it be helpful if I just kind of reiterated what the exercise is? The lecture was intended to give a feeling for some of the qualities that we're attempting to explore, which is the idea of dissipative, resilient, cellular textiles. And in the talk, I tried to emphasize that this is rather different in its quality than the way we're classically taught. The way we're classically taught in design to make clear, bounded things, where something is a figure. It has a truth to it by virtue of its boundary. That's a long-standing Western design tradition where the simple, reductive thing is the best of all. And I showed an image like this, which is, glorious in its clarity, but at the same time is very, very different than the same kind of material like this, in which a snowflake or something which has as much reaction phase as possible is playing. And the absurdity of saying that the clear, bounded, walled thing is better, more virtuous than the radically dissipative, precarious one is, I hope, something that we can meditate on. So finding the qualities of how to work with dissipative forms. When I say dissipative, I mean energy shedding. And so exposing a reaction phase to the world as opposed to consolidating it, making it as reductive and clear and powerful as possible. It's almost as if we're trying to be unapologetically fragile in the work. So there's an agenda then in the way you might assemble the elements. So what are the elements? Well, please gather a couple of hundred of something. It could be as simple as a paper clip or bamboo skewers or leaves of grass, or you could work in automated ways and cut materials up. But we're making a cellular textile out of individual filamentary cells. The way you fasten them together might be significant, and it's fine to just hack them or sew them or glue them or clip them together. Let's find out what the relationship is between these elements, and then how they behave will be something that will be really, really interesting to discover from playing with them. So this is a first step of building up textiles, and then we're going to go on to making them into a garment by the end of the week. Yes, Hannah.
Can I just reiterate what you said so I make sure that I understand it?
Sure.
Yeah, so the idea is to take, you said like 100 of something and create a textile with it?
Yep.
By fastening it or connecting it together in some way?
That's right.
Okay.
To create, because to make a textile, a fabric, out of an assembly of many, many elements. Now, you're completely welcome to use a counterpoint of a couple of different kinds of element. It could be a periodic system. I'd like you to have a lot of elements, large number, so that it really can build up a rhythm and a grain. And if it could be groups of groups of groups, that would be wonderful. Does that help?
Yeah, that's awesome. Thanks.
Cool. So Victoria and Roshni, do you also have kind of a sense of this first exercise and how to pursue it?
Yes.
Great. I think that we're also going to be ending up teaching each other a lot. As soon as we see what each other has done, that'll no doubt give us more ideas. So I hope it'll be a really pleasurable exercise. And please, by all means, show images of things that inspire you as well. And we're going to kind of build this up out of those kind of cycles. But I hope it can end up being a kind of a manifesto for sensitivity and resonance. Cool. Okay. Well, I think that maybe Basecamp is working again. I hope that you'll find that okay. Don't hesitate to reach me by email, or message me. Well, I'll try to kind of stay monitoring things if you do have any questions. Otherwise, I'll really look forward to seeing you tomorrow.
Thank you very much.
Okay. It's great to see all three of you. Take care.
Bye.
Bye-bye.